Atomic spectrum. When white light travels from one medium to other medium, it deviates from its original path. Okay? When it is passed through a prism, wave with shorter wavelength deviates more, and which is having more wavelength will deviate less. Okay, let us take the white light. We can observe this when it is passing through a prism. Take this white light when it is passed through a prism. It consists of different waves of a different wavelength in the visible region. That is, it ranges from violet to red. Violet is having shorter wavelength. It is having the shortest wavelength. That deviates more than the other colors. Then at last red color. Red color is having the longest wavelength, which will deviate less. So when a white light is passing through a prism, we can observe a series of colored bands, okay, in the visible region. This series of colored band is called as spectrum. Okay, that is, white light is spread into a series of colored bands, which is called as spectrum. Okay, there are three types of spectra. Okay, that is, three types of spectra are three types. Spectra. First one, continuous spectra. Okay. Then absorption spectra. Third one, emission spectrum. Okay, these are the three types of spectrum. Let us discuss one by one. Continuous spectra. Example for continuous spectra is rainbow in the sky. Okay, so white light contains different colors in the order Vibgyor. Okay, so violet is having shortest wavelength and red is having more wavelength. Okay, in the rainbow, if we observe, we can see all these colors ranging from violet to red, but these colors merges and seen as a single band of different colors. Okay, single band of different colors. Okay, this type of spectrum is known as continuous spectrum. Such a spectrum is known as continuous spectrum because here the different colors are continuous. Okay, so rainbow is an example of continuous spectrum. Next is absorption spectra and emission spectrum. Okay, when electromagnetic radiations interacts with matter, atoms and molecules absorb certain energy and they reaches to a higher energy level called as excited state. Okay, so when electromagnetic radiations interacts with matter, atoms and molecules present in the matter will absorb certain energy. Okay, energy, and reaches to a higher energy state. Okay, higher energy state called as excited state. Okay, this is called as excited state. And this excited state is highly unstable. So what will happen? They will return back to the lower energy state by emitting certain radiations. With these radiations having various regions of electromagnetic spectrum, and they produce spectra. Absorption spectra and emission spectra are obtained like this. Okay, so this state is unstable. Okay, so they return back to the lower energy state. Energy state by emitting certain radiations. Of various regions of electromagnetic radiation. Okay, various regions of electromagnetic radiations. So due to this electromagnetic radiation spectrum, okay, due to this absorption and emission of radiations of various regions of radiations of various regions of electromagnetic spectrum, two types of spectra are obtained: absorption spectra and emission spectra. Absorption spectra is obtained when energy absorbs and reaches to the higher energy state, and emission spectra is obtained by the emitting of radiations when they fall from higher energy state to the lower energy state. Now let us explain one by one. Next, absorption spectra. When electromagnetic radiations passed through the sample, okay, it absorbs certain radiations. It absorbs certain radiations of different wavelengths. Okay. So by this we can obtain a continuous spectrum. Okay. But along with it, some radiations having wavelengths are missing. Okay, the missing wavelengths, okay, during this absorption, certain radiations are missing. Okay, of different wavelengths are missing. Okay, the missing radiations corresponds to the absorbed radiation. Okay, produces dark space in the spectrum. This spectrum is known as dark space in the spectrum. Okay, this spectrum is known as absorption spectrum. Okay, so during this absorption, what will happen? Certain radiations are missing. This missing radiations corresponds to absorbed radiation, produces dark space. These are the dark spaces. Dark lines are obtained in the spectrum. This spectrum is known as absorption spectrum. Okay, we can observe from the spectrum. So these are dark lines, and all the other space are colored. Different colors of different bands are obtained, and between all these colors we can see different dark space. This spectrum is known as absorption spectrum. Next, emission spectrum. So When electromagnetic radiation interacts with matter, atoms and molecules absorbs energy. Due to this absorption spectra is obtained. Okay, and they moves towards the excited energy state. Since it is highly unstable, they return back to the lower energy level. Okay, due to the unstable excited energy state, matter, the atoms and molecules or electrons present in atoms and molecules return to the lower energy state by emitting certain radiations. Okay, by emitting certain radiations in the electromagnetic spectrum. Okay, in the electromagnetic spectrum. Okay, and they produce a spectrum like this. Okay, so these different lines shows the colored bands, colored lines. Okay, colored lines like red, blue, etc. Different colored lines are obtained. All the spaces between these colored lines are dark space, dark in color, and these lines are bright colored lines. Okay, so such a spectrum is obtained due to this. Okay, this spectrum is known as emission spectrum. Okay, now an important point between the emission spectra and absorption spectra. Absorption spectra is like the photographic negative of the emission spectrum. Photographic negative of the emission spectrum. Okay. So these are the three important types of spectra. Okay. Next we are studying about what is spectroscopy. What do you mean by spectroscopy? Spectroscopy means the study, it is an important branch in the chemistry. Okay, so it is a study of absorption spectra and emission spectra. Okay, it is a study of absorption spectra and emission spectra. Now this emission spectra is discontinuous. Okay, it contains discontinuous bands. If it do an experiment with a gaseous sample, okay, with a gaseous sample, using the gaseous sample, if we are doing an experiment, we can observe emission spectra. Okay, and emission spectra contains different lines or bands of different colors. Okay, different colors are obtained as bands or lines. Okay, lines of spectra are obtained. So emission spectra is also called as line spectra or atomic spectra. Okay, this emission spectra is an important application in spectroscopy. Okay, so different emitted radiations is identified by the appearance of bright colors in the spectrum. Okay, so line emission spectra, this is very important in the study of electronic structure of atoms. The study of electronic structure of elements or atoms. structure of different elements. Okay, so this is an important application. Is used to identify an unknown element. Okay, identify an unknown element using line spectra is given. That is using line spectra if line spectra is given. Okay. Okay, line spectra of an unknown element is similar to that of the fingerprints of a person. We are identifying a person by his fingerprint. Okay, identify a person by his fingerprint. Okay. Like this, we can identify an unknown element by using its line spectrum. How can we identify? By matching the line spectra of the unknown element with a known element. Okay, if the line spectra are same, the element is the given compound. Okay, so this shows that line spectra of an element will never repeats. Okay, that is just like the fingerprint of a person, line spectra of a particular element will never repeat. Okay, this property was discovered by Robert Bunsen. Bunsen discovered this to identify an element. Okay. So, for example, helium in sun is discovered by the spectroscopic method. Okay. Okay. Lots of other elements like rubidium, then cesium, indium, gallium, scandium, etc. are identified by using this line spectra. Okay.